Today's lesson is on finding the volume of pyramids, cones, and spheres. We will learn the formulas, find the important parts of each of the shapes, and then apply the formulas to find the volumes. Just like in a prism, each pyramid has a base, and the other sides are called its lateral faces. The lateral faces are always triangles, and the base is not necessarily a triangle, although in this case we do have a triangular pyramid. The base also names the shape, so a square pyramid over here. This one is a square pyramid, and the base of the second one is a triangle, so that is a triangular pyramid. Also, just like in a prism and in a cylinder, cones and pyramids have a height that is perpendicular to the base. So the height goes from the point at the top, called the apex, perpendicular to the base. Cones and pyramids also have another part called the slant height, and the slant height goes from the apex to the midpoint of one side, forming a right triangle inside that pyramid. Here also we have the slant height here would go from the apex to the midpoint of one side, forming that right triangle here on the inside, and that will allow us to use the Pythagorean theorem to find those missing parts. We also need to talk about oblique versus right solids. Yesterday we talked about a right solid having a height along its edge, whereas an oblique solid has a height that is shorter than its edge. Here these prisms and cylinders have a height that is shorter than the edge. It's the distance between the bases. And we have the same thing with pyramids and cones. In a right pyramid or cone, the height goes from the apex to the center of the base, right apex to the center of the base, whereas in an oblique pyramid or cone, the height still goes from the apex perpendicular from the base, but it no longer hits the center of the base. Here we have the volume formulas for pyramids and cones. Again, the big B represents base area, so we would first find the area of the base of our prism or of our cone. And H again represents the height. The height is again the distance from the apex to the base of the pyramid, and we measure that perpendicularly. Same with of the cone. It is perpendicular to the base. Note that again we have this special formula for the cone where we replace the base spot with pi r squared because that's just the area formula for a circle. So let's try some examples. I'm going to write down my volume formula. The volume of a pyramid is 1/3 base area times height. And now I'm going to find my base area. In this case that's a square. And I'm going to find my height, which looks like it's going to require me to use the Pythagorean theorem. So for my base, I'm just going to pop out that square. Since we know that it is a square pyramid, I know that my base is a square. So 16 by 16 gives me 256 square millimeters. In this problem, we need to find the height, h, but we are not given the height. We are only given the slant height of 17. So slant height symbol is a cursive lowercase l. The height is our unknown, but we do know that from the center to the midpoint of the edge is half of 16. So I have an 8 here, and I'm going to pop this triangle out to help me figure out my height. So I have a perpendicular height that I need to find. My slant height is 17. Half of the base edge is 8. That is a triple, 8, 15, 17, which gives me a height of 15. Again, it is imperative that we pop these shapes out so that we can see all of the different pieces that we need. I would recommend using colors to highlight which pieces represent which areas. So I have my red base at the bottom. I have my blue height that goes from the apex perpendicularly down to the base, and now I am ready to make my calculations. So volume equals 1/3 times 256 times 15, which gives me 1,280, and I have millimeters times square millimeters gives me cubic millimeters. In our next example, we're going to calculate the volume of a right circular cone. Because it is a circular cone, it's just telling me that the base is a circle, and right just means that it is not oblique. So our height is from the apex right down to the center of the circle. So I'm going to need to find the height, and I'm going to need to find the area of the base. My formula is 1/3 base area times height, or I can write it as 1/3 pi r squared times height. Remember that base area is pi r squared, so those are really the same formula. So to find the area of my base, I need the radius, pi times 5 squared. That's going to give me 25 pi. And to find my height, I am going to have to pop another triangle out of this picture. So I have this right triangle here. If I pop that out down here, I have a leg of 5, a leg of the height, and a hypotenuse of 13. Remember from our triples, that's a 5, 12, 13. So my height must be 12. You can always do the Pythagorean theorem as well. 5 squared plus h squared equals 13 squared, and you will get that height of 12. Now I'm ready to plug into my formula. 1/3 times 25 pi times 12. That's going to give me 100 pi, and my units are cubic centimeters. If I want to, I can also plug that into my calculator and get approximately 314.16 cubic centimeters. The last shape we're going to talk about today is a sphere. And a sphere is defined to be the set of all points equidistant from a given point in space. So if I start with this center point, then every point that is the same distance from that point defines a sphere. All of these are called the radius of the sphere. Together they are radii. So my formula, 4/3 pi r cubed, means I only need to know the radius in order to find the volume. So in our first example, we are given the diameter. We're going to need the radius because our formula is 4/3 pi r cubed. So I need to find the radius r. That's our 7 inches here, half of the diameter. And now I'm ready to calculate. Volume equals 4/3 pi times 7 cubed. So 4/3 times 7 cubed is 343. And when I multiply that by 4, I get 1,372 thirds pi. I can also plug that in my calculator and get approximately 1,436.8 cubic inches. In our last example, we're going to be given the volume and asked to solve to find a radius. So we have a soccer ball globe constructed in 2006 for the World Cup soccer tournament. We are assuming that the globe is a sphere, and we are given the volume is 47,916 pi cubic feet, and we are looking for the radius. So because I'm given the volume, I'm going to write down my volume formula, 4/3 pi times r cubed. And I'm going to plug in what I know. I know that the volume is 47,916 pi, and I'm looking for my unknown radius. To solve this, I'm going to multiply sides by 3/4. That's the reciprocal of 4/3. That way this equals 1, and I end up with pi r cubed on the right, and 3/4 times 47,916 gives me 35,937 pi. I can then divide both sides by pi, and I'm going to take the cube root of 35,000. The cube root button on your calculator looks like this. It is on the phone calculator. It is also on the TI calculator under the math key, which is on the left near the x squared key. When you take the cube root of 35,937, you get a radius of 33, because 33 multiplied by itself 3 times would give you 35,937. Also, don't forget that your unit here is going to depend on the unit that you started with. If you started with cubic feet, then your radius is 33 feet. So we've now talked about how to find and use volume formulas for 3 more shapes: pyramids, cones, and spheres. We talked about how to find the base and height of each of these, of the pyramids and cones. And we also talked about how to use the Pythagorean theorem to find any missing heights from a shape.